So College Board released 120 new math questions to their SAT question bank, and today I'm going to be solving some of them. So the first question, it says in rectangle PQRS, the length of line segment QS is square root 2344. So let's just label that real quick. QS 2344. Okay. And the length of side PS is 8 more than the length of side RS. So if RS, let's just say it's X because we don't know what it is, then PS would be X plus 8 because it's 8 more than RS. And then now we need to find the side length of the side QR. Well, since this is a rectangle, this side and this side are the same, and this side are the same. So if this is X, that would also be X, and if this is X plus 8, QR is X plus 8. So now what we have here is we have a right triangle with 3 sides, and we can use the Pythagorean theorem, a squared plus b squared equals c squared, to find x, and then once we have x, plug that back into x plus 8, and we get our answer for QR. So first let's set up the equation, the two legs here. So we can do x squared plus x plus 8 squared equals square root 2344 squared. And then when you square a square root, the square root just cancels out. So just type this into Desmos. X squared plus x plus 8 squared equals 2344. And I don't have to do square root because it cancels out with the square. Now let's look at where these lines intersect. Ignore the negative option because obviously a line can't be, obviously a length can't be negative. So that's going to be 30 for x. And if x is 30, then x plus 8 would be 38. Because we're trying to find QR, so QR is 38, and that's your final answer. Okay, so next question. The sum of the measures of two angles in a triangle 64. What is the measure of the third angle? So this one's pretty easy. Imagine you have a triangle, and then let's say these two angles add up to 64. We're going to find the third angle. Well, we know in a triangle, all the angles add up to 180, right? And if two of them are already 64, you can do 180 minus 64 to get the other angle, which would be 116 degrees. So your answer would be C. Otherwise, and the others would just be wrong. Okay, so question 3, it says, in the figure shown, line K intersects line R and S. If W equals 147, which additional piece of information is sufficient to prove that lines R and S are parallel? Okay, so we're trying to prove that R and S are parallel. So if W is 147, let's write that down, 147. Okay, it's pretty bad handwriting, 147. Then we need to find something that would prove these two are parallel. So this looks kind of awkward because it's kind of flipped of how you would normally see it. You would normally see something like this. And in this case, W would be right here. This is W. And we know that these two lines would be parallel if this angle was the same as this angle. And in this case, W and Y are these two angles. So if Y is the same as W, Y is also 147, then these two would be parallel. So the answer would be B, which says Y equals 147. X being 33 doesn't really prove that. If any, that doesn't prove because it has nothing to do with line S. X being 33. Y plus W plus Y equals 180. W plus Y equals no. That's false because they have to be the same. Y plus D equals 180. No, that has nothing to do with line R. So yeah, it's just answer B. If W and Y are both 147. So it's just B. Okay, next question. The circle shown as the center at 0, 0, or the origin. What is the value of K? So for this question, the easiest thing to do is just jump to Desmos. But first, we know that the center is 0, 0. And then from the center, this point, any point on like the outside of the circle, the center is a radius. So here to here is a radius. And the radius is 8. Because as you can see, the x value goes from 0 to 8. So radius is 8. That means the distance from here to here is also should be 8. So we need to find a value of K that makes the distance between these 2 points 8. Now if you jump to Desmos, let me just clear this, make a point, call it A, call it 0, 0. This is the center. Make another point, call it B, and then make it 2K. This is the point right here on the outside, right? And then now let's find the distance of these 2 points, A, B. And the distance between these points have to be 8. So I have to pick a value of K that gives us 8. And since we were given the answer choice, we can just do plug and chug. So first, let's try 6. No. 7. No. Was it 8, right? 8. That's not it either. Square root 60. And that gives you distance of 8 or radius of 8. So the answer for what is the value of K would be square root 60 or just D. So this next question, the table gives the areas and perimeters of 2 similar rectangles where n is a constant. What is the value of n? So I'm going to rewrite this table in a way that makes sense to me. Okay, rectangle A, rectangle B, and then perimeter, okay, perimeter I'll just call L for like length, and then area, just do A for area. So the area for rectangle A has an area of 630. Okay, and then rectangle B has an area of 2,520. And rectangle A has a perimeter of 210, and then rectangle B has a perimeter of n. So we're going to find the value of n, and then this can be done by finding what is like the factor that we have to multiply from the area of A to get the area of B. So if you do 630 times 2520 over 630, these 630s cancel and you would get 2,520. But you can actually simplify this factor. Do 2,520 divided by 630, which is 4. So the area of rectangle A times 4 gives you the area of rectangle B. Well, we can't use this factor if you want to find, you can't use it if you want to find the perimeter of B, because this is area and this is in units squared and this is in just in units. So we have to take the square root of this, square root of 4, which is 2. So you have to multiply 210 by the square root of 4, or multiply by 2, which gives you 420. And that would be your answer for n, or the perimeter of B. So that's just the final answer. Next question. In triangle ABC, let's draw it out. It says A is 52 plus A, 52. AC is 30. AC is 30. BC. And PQR, draw like this. PQR. Measure of angle P is also 52. Okay. And PR is 120. Which additional piece of information is sufficient to prove that ABC is similar to triangle PQR? So to prove if a triangle is similar, there are 3 different like things you can use. You can use the side theorem if all 3 sides are related by some like factor, or they're all scaled by a factor. You can use angle if 2 angles are the same, and the 3rd angle must be the same, and then the triangles have to be similar. Or you can use side angle side. If 2 sides are scaled by the same similar factor and the angle in between them is the same, then they're similar. So let's see. Let's look at answer A. Answer A says AB is 50 and PQ is 50. AB 50, PQ 50. No, that would not prove that they're similar, because as you can see, if you look right now, AC is 30 and PR is 120. That means the factor is times 4 to get from AC to PR, and this just breaks that rule. This makes it times 1. That can't work. B says AB is 50 and QR is 200. So AB 50 and QR is 200. This also doesn't work, because while it does follow the times 4, it wouldn't work because it's not one of these 3 things I just mentioned here. Because look, this is side angle side, because these are 2 sides and it's angle between. But this one, if it was like, let's say if it was PQ, then it would work. But the side is giving us right here, so this doesn't mean it's necessarily true, right? So you can't use this one either. All right, And then C says the measure of angle B and R are 32 and 96 respectively. So B 32 and R 96. If B is 32, I mean C has to be 96. And if R is 96 and Q has to be 32, and now all these angles would be the same. And if all the angles are the same, then they're obviously similar. So the answer would be C. Let's just look at D. D says the measure of angle B and Q are 52 and 32 respectively. No, this would just be wrong because you wouldn't get angle. You wouldn't get two of the same angles. These two, the other two would be different, and that would not prove that they're similar. So the answer is just C for this one. Okay, next question. The graph of the given equation is a circle in the xy plane. The point QS lies on the circle. Which of the following is not a possible value of Q? So QS is just like another way to say X, comma Y. They're just trying to confuse you. So it's just saying which values of X from the answer choice would not touch the circle or would not fall in like inside of it. So easy way to do this is just graph the circle. X minus 3 squared plus Y plus 16 squared equals 289. Now zoom on a bit. And this is our circle, right? So what we can do is just set X, make a line with X equals, and then just pick one of the answer choices, and whichever one is like away from the circle is the correct answer choice, is correct, because it says which of the following is not, right? So let's try X equals negative 17. And as you can see, the first answer is correct because negative 17, this line is nowhere near the circle. It's not touching it and it's not inside it. So it's not a possible value for Q because it says Q lies on the circle. So the answer is just A. You could check the other ones, but those would be correct. So the answer is A. Okay, so next question. This one's really easy. Rectangle ABCD shown has a length of 7 units and a width of 2 units. So 2, 7, what is the area? 2 times 7, 14. So it's just C. Next one. This one's a bit harder, but at the same time, it's also really easy. So it says a rectangle is formed by the 4 points shown. What is the area in square units of the rectangle? So if you just connect these dots right here like this, and then we want to find the area. So we have to find from here to here the width, and then from here to here the length. Just multiply those two to give us the area. And there's a really easy way to do this on Desmos. Just plot 3 points, this one, and this one, and then find the distance between this and this, distance between this and this. And those would give you your length and width values, and you can just multiply them. So let's jump to Desmos. First point we're going to plot, let's going to call this A. It's going to be at 4, 5. So let's make a point called A. It's going to be positioned at 4, 5. Label it A. And then another point, this one we'll call it B. And it's at 7, 1. So B equals 7, 1. And then the third point is we're going to call it C, and it's at negative 4, negative 1. C equals negative 4, negative 1. And then label it C. All right, now what we can do is use the distance function like we've done before. Find the distance between, distance between A and B, because that would give you your width, and it's 5. Let's just label that 5. And then distance between A and C, that gives you the length, 10. So the area, length times width, 5 times 10 is just 50. That would be your answer. All right, next question. This one seems hard, but it's also one of those questions that seems hard, but it's just very easy to solve. So it says in the given equation where t is a constant, the given equation where t is a constant defines a circle in the xy plane. The radius of this circle is square root 83. What is the value of t? So in my mind, I'm thinking the easiest way to do this is just graph this in Desmos and then test these values for t, and whichever one gives you a radius of 83 would be your answer. So let's jump to Desmos. Oh, no. Okay. And then x squared plus x square root t plus y squared minus y minus 65 plus y squared. Yeah, okay, and then, so usually what I like to do is I like to pick if I'm picking from answer choice of numbers and I'm trying to test, I'm usually going to pick the one that's in the middle. So if its answer is too high, then I can like go down and pick the smaller number. If it's too low, I can go higher and pick a higher number. So I'm going to go with B. That seems to be closest to like the middle kind of. So t equal to 71. Now we have our circle. And the radius has to be square root 83. Square root 83, which is this decimal. So what we can do is get the highest point on the circle right here. Plot it. Same thing right here. And then we can label them A, B. And the distance between A and B divided by 2, because from here to here is the diameter and we need the radius. And that gives you 9.11043. And then that's the exact same as square root 83. So yeah, we were right. So the answer is just B, 71. You could test the other ones too, but they just wouldn't work. And this is the easiest way to solve this question. So let's look at the next question. In the figure, BC is parallel to DE. If the length of DE is 147, and the length of AE is 245, AE 24. What is the value of tangent of x? So as you can see, this is one big right triangle, but it has two smaller right triangles in them. Or sorry, yeah, it's one big right triangle with another triangle right here, and then this one right here. And both these triangles are similar because they share this angle. They both have 90 degrees, and that's automatically angle-angle similarity. So this angle has to be the same. So x degrees right here, this is also x degrees. And we want to find tangent of x. Now we don't have any of like these sides. We don't have AC, AB, or BC. So what we can do is we can find tangent of x right here, because these two angles are the same, because the triangles are similar. And that would just be the same as tangent of x right here, because since they're similar, their trigonometric ratios are the same. So what we can do, we can find this side, this leg right here, jump to Desmos. We can name that leg x. So x squared plus 147 squared equals 245 squared. This is the Pythagorean theorem. And then zoom out, and then we get 196 is the value for AD. And now tangent is always opposite over adjacent. So if you look at this, opposite of x is 196. And then the adjacent is 147. Because this would be the hypotenuse. So this would be your answer. So 196 over 147. 196 over 147, which is a C. So that's going to be your final answer for that question. Alright, so this question is actually kind of difficult. So in the figure, AD and BC intersect at point D. If the length of BD is 5, let's just label that. And the tangent of angle CAD is 1.3. What is the length of AD? I'm going to find this length. So we know the tangent of CAD is 1.3. That's going to be important because we're going to be using proportions, since there are like 3 similar triangles in here. So we have this big right triangle, right? And with this altitude or line 80, we get a smaller one, like the smallest one, and then a medium sized one. So, and all 3 of these are similar. So we know CAD, this angle, has a tangent of 1.3. So what we can do is we can find the corresponding angle to CAD in this smaller triangle, and we can use proportions to solve for AD. So look, 90 degrees is across from the largest side. So this isn't the angle because this is 90 degrees and it's across from the largest side. this angle right here, small angle C, is across from the smallest side. So, and that's not the angle we need. So it's not this angle either. It's the one across from like the medium size or whatever. So if you look, this angle is across from this, and this angle is also across from this. So these are the corresponding angles. So using that, we can now set up our proportion. So we know tangent is opposite over adjacent, right? And since we've determined that the angle that it's corresponding to CAD is ABD, the tangent for ABD is opposite over adjacent. So opposite would be right here. Let's call it X because we don't know where AD is, over adjacent, which is 5. Okay. And that's the same as 1.3 because they're all, these are similar triangles, and similar triangles have the same trigonometric ratio, right? So to find X or to find AD, you have to do 5 times 1.3. So let's just do that. 5 times 1.3, and you get 6.5. So the length of AD is 6.5. It's hard in the sense that you have to like kind of figure out the corresponding angle, but other than that, there's not much math involved. So you just have to think about it. What is the perimeter of an equilateral triangle with a height of 39 square root 3? So let's draw an equilateral triangle real quick. And in this equilateral triangle, all 3 sides are the same, and all 3 angles are the same, and they're all 60 degrees. They have to add it to 180. And so the height, if you just draw a line straight down like this, is 39 square root 3. And then since we drew a line straight down, this angle right here becomes 90 degrees. This angle right here is still 60 degrees. But this just halved the 60, so it's the angle right here is 30 degrees. Now, if you notice, this is a 30, 60, 90 triangle, so we can use the properties of those triangles to find the perimeter. So I'm just going to draw another triangle here. It's a 30, 60, 90 triangle. This side is x square root 3. You get this on your formula sheet in the test, by the way. And this side is just x. This side is 2x. Hypotenuse is 2x. And if this side is x square root 3, and then we know the height is 39 square root 3, we know x is 39 because you can just cross out the square root 3's in both, right? So if x is 39 right here, then the hypotenuse, this side right here, is 2 times x, which is just, oh, am I going to decimal? It's just 78. So if we just redraw the triangle, so it looks neater, this side is 78. And we want to find the perimeter of the equilateral triangle, right? And all 3 sides are the same. So you do 78 times 3. 234, and that's the perimeter, so your answer is C. Okay, next question. Acute angle P has a measure of P radians, and acute angle T has a measure of T radians. The function g is defined by g of x equals P times 8 to the x plus 6t if this is true, which of the following represents g of 0 in terms of t. This question is very hard, and most of you probably have never done anything like it. So to solve this question, we need to pay attention to this right here. It says sine of P, and P is the angle in radians, is equal to cosine of T. Anytime you have 2 angles, or like 2 angles, anytime you have 2 angles and the sine of one angle is equal to the cosine of another, that means those 2 angles are complementary, which means they both add up to 90. So P plus T equals 90. Okay, that plus sign is very bad. P plus T is equal to 90. But if you look at the answer choices, it's all being done in radians. So it's probably better if we don't write 90 and if we write pi over 2, which is 90 but in radians, right? Okay. Now that we have that, says the function g is defined by this, and which of the following represents the value g of 0 in terms of t? So if you're plugging 0 for x, then you would get p times, well, 8 to the power of 0, anything to the power of 0 is 1, so it's just p plus 6t. So g of 0 is just equal to p plus 6t. And now we want to find the answer in terms of t. So we want to get rid of this p. Well, what we can do is we can reuse the equation above to find p in terms of t and substitute it back in and get our answer. And another reason why we converted 90 to pi over 2 while we made it in radians, because p and t are actually in radians, so this also has to be in radians. Anyways, so we can use this equation to determine that p is equal to pi over 2 minus t. Plug that into here, we get g of 0 is equal to pi over 2 minus t plus 6t. 6t minus t is 5t, and then there's a plus pi over 2, and that's g to the 0. So this is our answer, 5t plus pi over 2, 5t plus pi over 2, so it's just d. A circle in the xy plane has the equation this, where k is a positive constant, which of the following gives the center of the circle and its radius. The center is the opposite of whatever the signs are here, so it's negative 19, negative 17, so the center would be 19, 17. Look at the answer choices, same for all of them, so we can't eliminate any yet. And which of the following gives the center and its radius? Okay, so in the equation of a circle, the radius is actually r squared. So to find the radius from this, you have to take the square root. So square root of 64k squared is just 8k. Because square root of 64 is 8 and square root of k squared is k, so 8k. So the answer would be B, because that gives a radius of 8k, and then everything else is wrong. A right circular cone has a height of 22 centimeters and a base with a diameter of 18 centimeters. The volume of this cone is n times pi centimeters squared. What is the value of n? So if you just draw a cone, actually we don't even need to draw a cone for this. So if the equation of the volume of cone is the volume equals 1/3 pi r squared times height, okay? And we can get rid of the pi because pi, it's in terms of pi, the answer, right? So we just want to find n. So what we need to do is 1/3 r squared times height, and the diameter is 18 and radius is half a diameter, so radius is 9 squared, and then height is 22. So plug this into decimals, 1/3 times 9 squared times 22, 594. So, and that would give you a value for n. So what is the value of n? 594. And yeah, we remove pi because, as you can see, it's in terms of pi. So we just need to ignore that. We don't need to multiply by pi. And so yeah, the answer is 594. Okay, next question. In the figure, LQ intersects MP at point R and LM is parallel to PQ. The lengths of MR and RP are 8 and 14 units respectively. MR 8, RP 14. The area of LMR is 36 square units. LMR 36 square units. What is the area of PQR in square units? So these two triangles, they're similar because if you can see they share this angle. So one of their angles is the same. And if these two are parallel lines, LM and MP, and this line, like imagine this line was a bit longer. That means these angles, just draw this like this. these angles are also the same. Using the fact that they're parallel lines, and these would also be the same. So basically what I'm just trying to get across is these two triangles are similar. You don't really have to prove it. It's kind of obvious that's what they're saying here. Because how else could you solve for the area of PQR if they weren't similar, right? So let's make a table, and let's call that first triangle LMR. And the second one RQP. And then the length of one of the sides of LMR is 8. RQP is 14. And then the area of LMR is 36 square units. And we don't know the area of RQP. So we're going to do the same thing we did in an earlier question, which is, so what number times 8 would give you 14? Well, it would be 14 over 8, which is also simplified to 7 over 2. And then we need a factor to multiply the area by to get the answer. And we can't use 7 over 2 because this is in units, it's unit squared, so we just square 7 over 2. Oh, it's 7 over 4, not 7 over 2. That's what I did wrong. 4. Simplified. Oh yeah, so it's the factor is 7 over 4 because 14 over 8 simplifies to 7 over 4, not 7 over 2. So just change this from a 2 to a 4, and then you get, 441 over 4. Yeah, so the answer is D. That's not bad. All right, next question. Which expression represents the area in a square inches of a square with a side length of 35 inches? That's pretty easy, but I'll just draw it out. So we have a square side length 35 inches, which means all the sides is 35. All sides are the same. Area would just be side squared for a square, so 35 squared would be our answer. It would just be D. All right, next question. Okay, this one is actually really hard. In right triangle XYZ. Okay, let's just draw it. XYZ. Okay, I'm gonna try to make this bigger because it'll just be easier for this question. Yeah. X and Z are acute angles, meaning Y is the right angle. Point R relies on XZ such that YR is perpendicular to XZ, so altitude in other words, because this. Okay. The measure of XZY is A degrees. XZY, A degrees. The measure of XYR is B degrees. XYR, B degrees. And the length of XY is 19. And sine A equals 12 over 13. What is the value of tangent of B? Okay. So to solve this question, okay, first thing that we can do is we can get another sides. We can label more sides. So sine is opposite over adjacent. So if sine of A is 12 over 13, opposite 12. Sorry, opposite of hypotenuse. So hypotenuse will be 13. We just label the sides. Let me label it a little away from B. It's opposite over adjacent. It's opposite over hypotenuse. I don't know why I said adjacent. 12, 13, opposite over hypotenuse. Okay, we have these two sides, and then it says, what is the value of tangent of B? So when you make an altitude, you have 3 similar triangles now, but we're ignoring the big overall triangle, and we're just going to focus on these 2 smaller ones. And it will be easier if we draw them like this. Right angle, which is Y, and then, oh wait, no, it's R for this one. Y, X, this one is also R, Z, Y, okay, and the hypotenuse is 13, and this side is 12, and it's opposite from A, And then for this one, B is the one in Y, so this is B right here. And XY, which is the hypotenuse for this triangle, is 19. Okay, so if you take these small triangles right here, and if you draw them out like this, it'll be much easier to understand the question. What is the value of tangent of B? Okay, so these two triangles, they're similar. These two triangles are similar. So tangent of B is the same thing as tangent of A. Because as you can see, we redrew these two triangles, and since they're similar, the angles are the same, and B corresponds to A. So these are the exact same angles, A and B. So if we can find tangent of A, that'll be the same thing as tangent of B. Because we don't have enough information to get these sides, but we can get this side. So this is actually a very common Pythagorean common right triangle. It's just going to be 5. Because 12 squared is 144, 5 squared is 25, 25 plus 144 is 169, which is 13 squared. So this side is just going to be 5. And that's just something you should remember, because these are very common Pythagorean triples, I think they're called. And what is the value of tangent of B? So we can just find tangent of A. Tangent is opposite over adjacent. So the opposite is 12, adjacent is 5, so 12 over 5 is going to be for the value for tangent of A, but it's also the same value for tangent of B. So that's going to be our final answer. Okay, so this will be the last question for today. The edge length in inches of cube Y is 3 over 38. The edge length in inches of cube X. The surface area in square inches of cube Y is n times the surface area in square inches of cube X, which is the value of n. Okay, so this is like another like proportions from length to area from units to units squared question. It's like the third one, I think. So these are actually getting pretty common now. So it says the edge length in inches of cube Y, Y and just L for length, is equals 3 over 88 edge length in inches of cube X. X. Okay. The surface area in square inches of cube Y. So Y surface area is, so another equal sign, n times the surface area in square inches of cube X. What is the value of n? So this is just like another one of those finding the factors. So this is a length, so this is in units. Surface area, so anything with area, units squared, and then volume would be units cubed. So just take this factor and then square it, and that will be your value for n. So if we just do 3 over 88 squared and make it a fraction, we get 9 over 7,744, and that's A. So that's our final answer. And yeah.